Hello friends, in this video series I will be teaching you the hard surface modeling techniques that I think are essential to know if you want to make detailed hard surface models. These techniques pair well with any model, but specifically for a subdivisions workflow, meaning that unlike other tutorials on this type of modeling, I will teach you good practices that will maintain a satisfying quad topology with good edge flow and density. If you stick through this video, and if you enjoy it, make sure to like and subscribe, as I hope to make a similar, extensive tutorial on hard surface rigging, a topic that can seem extremely confusing at first, but becomes very enjoyable once you understand the core concepts. For some context, I have been making hard surface models and robots for the better part of a year now, including works that I submitted for 3D projects and competitions, such as for CG Boost's Robotic Wildlife Challenge, Punisher's recent Eternal Ascent Challenge, and CGMA's Prop Modeling course. With each project, I learned more and more about the hard surface workflow, including techniques, tips, and tools. My goal is to share the knowledge I've gained through clear, direct, high-quality tutorials, condensing months of learning into an easily digestible series of follow-along videos. Precisely shaped holes and cuts in models is one of the, if not the most important feature of the hard surface workflow. In Blender and many other 3D softwares, cutting holes is mainly done using Booleans, where one mesh is used to cut or merge with another. In this section I will teach you when to use Booleans, and how you should be thinking when using Booleans, to ensure the resulting topology stays clean and even. Let's start simple. I want to cut a circular hole in this plane. You might be thinking of spawning in a cylinder to cut through with a Boolean operation, but this is not the easiest way, and I will explain why. If we look at the resulting topology, it is not clean at all and will require you to connect each of these vertices to the outer edges in order to create a quad topology. Let me show an alternative way to cut holes that is easier and simpler. For this method, you will need to have enabled the Loop Tools add-on, which is shipped with Blender, and you can find it by typing here. Now let's spawn in a new plane and go into edit mode. For a circular hole, we need at least 6 vertices, but using 4, 8, 16 or 32, any power of 2 really, is good practice. For this example, let's say I want a circular hole with 16 vertices. Let's subdivide this plane until I have the required geometry. Now I can insert the faces, right-click, go to Loop Tools and choose Circle. This creates a perfect circle with the selected vertices. Now I can delete all these faces and go back to object mode. You can see we now have an all-quad mesh with a circular hole, which was much simpler to create than with a Boolean. Now let's discuss the weakness of this method. The primary weakness is that it can be tough to work with when working on curved surfaces. Luckily, this is where Booleans thrive. Let's see an example of this. Spawn in a cylinder and give it 16 vertices. Before we cut anything, we need to add some loops to this cylinder until it has a neat quad topology, which is done in order to provide even geometry for our circular cut, similar to how we added cuts to the plane to give it more even all-quad geometry. Now let's try to use the Loop Tools method, insert these group of faces and right-click, Loop Tools, Circle. The result isn't great. You can try to disable the Flatten option, which will allow the circle to follow the curve of the cylinder, but the result is still unreliable. Instead, let's explore using a Boolean for this situation. Before we spawn in a cylinder to use as the cutter object, we need to know what resolution, or how many vertices it needs, because if we cut the main mesh with a cylinder that has too little or too many vertices, the difference in resolution will not allow us to have a quad topology, as there will be extra or missing faces. An easy way to find out what the resolution of your cutter should be is to select the grid of faces that we will be cutting into, insert it, and select the edges around the border of the inset. In the bottom right, we can see that I have selected 16 vertices, therefore our cutter should have a resolution of 16 vertices. Undo that inset, and let's spawn in our cutter object, a cylinder with 16 vertices, and position, rotate and scale it to fit in the required area. You can turn on wireframe mode to make it easier to position it. Make the cut and apply the Boolean in the Modifier tab for our mesh by hovering over it and pressing Ctrl+A, then delete the cutter object. The last step is to go back in edit mode and clean up our Boolean. You can see that the edges of the cylinder don't match up with the edges of the cut. Fixing it is very easy and requires some simple tools. Let's start from this top vertice and work our way around. Press the G key twice to slide one vertice into the other, making sure they are overlapping. You can merge by distance with the M key, or turn on automatic merging in the top right corner, which will automatically merge the vertices together when you move them close to each other. For edges that need to be connected to the cut area, you can select both vertices and press the J key, or press the K key to use the knife tool and create an edge between the two vertices. Make sure you are moving the vertices of the original mesh, not the cut area, as that will disrupt the flow of the circular hole. After this, you should have a perfect cylindrical cut in a curved surface. It may seem complex at first, but through practice, you will better understand each step of the way. Let's complete this example by going over the 4 steps to the Boolean workflow. 1. Prepare your mesh by ensuring the area you want to cut has even, quadrate topology. 2. Determine the resolution of your cutter by insetting the target area and counting vertices. 3. Perform the Boolean operation, apply the Boolean and delete the cutter object. If you are working with a non-destructive workflow, don't apply the modifier or delete the cutter, then you can edit the cutter in real time. 4. Go back into edit mode and clean up the cut area. This also doesn't apply if you are working with a non-destructive workflow. You might have noticed an important distinction between the two methods. When using loop tools, we must first prepare our mesh, ensuring it has the required amount of vertices to allow for the cut to be made. However, when using Booleans, we must not only prepare our mesh for the cut, we must also ensure the positioning of the cutter object is precise, and then we must go in after the cut has been made and clean up the geometry by merging vertices or adding edges with the knife tool. This is why the Boolean method is generally more complex and time-consuming, but offers way more control, which is why it is the superior method for working on difficult curved meshes. Let's try one final example. This time, we will try to replicate this shape, which has circular cuts on both curved and flat surfaces. Let's start by adding a UV sphere, going into edit mode, and deleting half of it. Select the middle loop and press the V key to rip this edge, turning it into a separate mesh. Delete this half and fill in the empty space using a grid fill. Change the offset to make the fill align with the rest of the mesh. If you want to take this one step further, you can align these vertices to make a more even grid, but don't worry, I will be covering this in a later section. Now we can check what the resolution of our cutter should be by insetting these faces. As you can see, we need a 24 vertice cylinder, so let's spawn one in, position it, making sure it cuts through the whole sphere, then perform the Boolean operation and apply the modifier. Now we will need to go in and clean up the cut. Remember to slide and join vertices, deleting unnecessary edges and merging the result. And just like that, we have a complex shape with a cylindrical hole cut through it, with great topology. The important lesson to take away from this exercise is, you only really need to use Booleans either when cutting into curved surfaces, or when the cutter is a complex shape rather than a cylinder or cuboid. Think of it as a backup tool rather than the primary method, which would be traditional modeling tools. The more experienced of you would have spotted 1 or 2 issues with these last few examples, like not adding supporting edges, but don't worry, it is because these are topics I want to discuss in their own sections, which leads me to the second essential technique for hard surface modeling, edge loops and supporting edges. See you in the next video. Remember to like and subscribe for more, and comment any thoughts or questions. See you there.